Today we're going to look at using simulations to calculate the probability of an event that may not lend itself well to an actual experiment. A simulation allows us to act out a situation whose outcomes are analogous to the original situation. Simulations are a way to estimate the results of an experiment without conducting the actual experiment. For instance, we can use a random number table to help us predict how many children will contract strep throat after exposure to the disease. You can see why this method is preferable to actually running the experiment of exposing a large number of children to the disease. Here's our problem. It is reported that 15% of people who come into contact with a person infected with strep throat contract the disease. Use a random number table to estimate the probability that A, at least one child in a 4-child family will catch the disease, given that each child has come into contact with an infected person, and B, exactly 2 children in a 4-child family will catch the disease, given that each child has come into contact with an infected person. To simulate the situation, we need to use a table that will allow us to easily assign numbers in a way to identify 15 out of 100 for the 15% contraction rate, and that will represent a 4-child family. If we use integers from 0 to 99, those from 0 to 14 could represent the 15%. We can use a random integer generator, such as this one found at random.org. We'll generate 30 sets of integers with 4 numbers per set. This will represent 30 families with 4 children each. We'll set the range of values from 0 to 99. This will allow the generator to randomly select numbers in that range. The display defaults to sort the 4 numbers in each group in ascending order. That would actually be helpful, but most random number tables aren't sorted for us, so we'll shut that off. Now we're ready to get our set of numbers. Here they are. We'll copy and paste them into a table. Here are the numbers that we generated online. They are arranged in a table for our simulation, and we are ready to answer the questions posed in the problem. Looking at part A, we want to know the probability that at least one child in a 4-child family will catch the disease, given that the children have come into contact with an infected person. We'll read the table from left to right and from top to bottom. Each group of 4 numbers represents a 4-child family. And in each group of 4 numbers, a number between 0 and 14 represents a child in that family who has become infected. Those numbers are shown in a different color in the table. 14 of the 30 groupings show at least one child contracting the disease. So the probability is 14 out of 30, or approximately 47 hundredths. Now let's consider part B, that exactly 2 children in a 4-child family will catch the disease after exposure. 2 of the 30 groupings show exactly 2 children contracting the disease, and they're highlighted here. So the probability is 2 out of 30, or approximately 7 hundredths. Remember that simulations give us a way to estimate the probability of an event, but of course they don't guarantee anything. If you notice in our table, there are no instances of 3 or 4 children contracting the disease. Thus, our estimate of the probability of more than 2 children in a 4-child family contracting strep throat after exposure would be 0. However, any mother of 4 children will tell you that it is entirely possible for all 4 of them to get sick at once.